All right. Well, Drew, welcome to Great Data Products, episode 1. Thanks for doing this with us.
Not a problem.
Um, yeah, as I said, I'm going to ask you to introduce yourself in a second, but before I go, I just want to explain a little bit like why we started this podcast, which is that we believe that understanding what makes a good data product is just very understudied. We've been doing it as a species for a while now, every now and then sharing data. There have been laws on the books saying, thou shalt open your data, or policies from research funders saying that, researchers need to open their data. But sometimes it goes well and sometimes nothing really happens with it. And I think we have enough experience under our belt now that like we can see there are a handful of data products that have come out that have had a huge impact on research. And we're at the point where we've got to figure out why those, what made them good. There's Eleanor Ostrom said this very somewhat famously, at least for me. I'm a big fan of hers, but she'd spent all of her life working on trying to understand how people share common resources that are limited. So like a fishery or a forest or grazing fields and stuff like that. And she's like, look, we know this happens. Like humans have figured out how to do this. We know it works in practice. Now we have to figure out how it works in theory. And I love that. So that's what we're doing, is trying to figure out. We know that some data products are really great. We want to tease out some theories as to explain why. And so for reasons that are obvious to me, but might not be obvious to everybody tuning in or listening, you were one of the first people I'd ever want to talk to about this. So why don't you explain a little bit about your background and what you do?
Yeah, first I want to put a pin in that quote you said, because I think one of the things that's crazy about that is like a fishery is like, it's a zero-sum game. Like that is a exhaustible resource source.
Yeah.
Data products have entirely different dynamics. Like you can go full like old school boing boing Cory Doctorow, data wants to be free. It's not
Right.
theft if you can reproduce it, but at the same time it grants you this immense advantage that then allows you to create more data in a way that isn't free. So it's
Right.
anyway.
Yeah.
So yeah, my name is Drew Breunig. I write a bunch on AI and data. I've been working in data. Helped run or ran data science and products at a company called Place IQ for about a decade, and then led strategy at Precisely when it came to the data and location intelligence business. I see data as a really interesting space because it's an intersection between humans and compute, essentially, because you're essentially converting humans or work of humans or observations made by humans into something that is programmatically readable. You can build products upon it, and that I also think the other thing that's interesting about that is that's not a one-way street. It's a two-way street. So you are converting humans into data, but at the same time, you're preparing data and figuring out how it can be leveraged to inform those humans.
Right.
So kind of making data human, making humans data. And that is an active negotiation, a borderlands, as it were, rather than just one way that comes in and goes out.
Oh man, fantastic. All right. See, yeah. This is a rich well to draw on.
Yeah, we can keep going. But
yeah, and what you just said about like Cory Doctorow and like sort of the economics of this, I think this is I'll just keep saying it out loud over and over again, is that like this is the Nobel Prize challenge, is like, can we figure out how data functions as a market good? Because it's weird, right? Like to your point about what Ostrom was studying were limited resources, which she called common pool resources, but with the assumption that they were limited and you needed governance to manage access to them. And just a quick primer on Ostrom for a lot of people. And I'm not like a full Ostrom scholar, but like a lot of what made that work was the fact that like you had to live with the people that you shared the resource with. And so if you were a jerk about it, like you would get punched. Like that's just part of it. And
yeah, I mean, I guess you can kind of say like that exists when it comes to like licenses, which is a whole different messy
oh
field,
yeah, we're going to talk
like,
about licenses.
Oh God, please don't. Like I like so much of my beef with licenses is that it's the will of people when the data wants to be free. And like the real way that you can kind of put your fingerprint on the market is you actually put the data out there in the shape and the form that is what you want, that makes
Yeah.
what you want in the world to happen. But the idea of releasing it and then gating it is just insane to me. It doesn't make any sense. It's backwards. You kind
Yeah.
of want the option, but you want to control how people use it, which is just like, why are you even bothering in the first place?
Yeah.
But yeah, and I think that's like, now you're getting into the familiar terrain of like the data is the new oil claims and other things
Hmm.
like that. And I feel like that's a quote even that we debated and wondered around and talked about for decades. And part of the reason we talked about it is because it made people who work in data feel important. Um,
Oh yeah.
it
Oh
made
yeah.
them feel like this justifies my paycheck, my job title, my power within the organization. But I don't really feel we got to the point where like data is the new oil became somewhat true until LLMs and
Yeah.
post Chat GPT. Um, Specifically, those were the engines needed. It's like you can create oil, but if no one owns an engine, no one has anything that they can do with it. Like that's kind of the era we were in when we were figuring it out. We could drill it, but we weren't sure what there was potential energy there, but what do we actually turn it into? And prior to that, there was one thing you turned it into, which was ad products. That was
Right.
the one thing you turned it into. That was the way to monetize. And now we're turning it into large language models and other things like that. So figuring out the economics of it, I believe, is hard because the other, like, I don't know. I think one of the things is like you can find so many different metaphors for this
Yeah.
because it's a complex thing and this complex bucket that like kind of reins it in. But I do think like one of the king metaphors for data is it's the platypus. Like it
Oh.
has eh,
Go.
because
Go on.
well, what is a platypus, Chad?
It's all sorts of crazy stuff.
Yeah, it's got a bill. It's poisonous. Lays eggs. Mammal. It's got fur.
Yeah.
Um,
Lactates in
uh,
a really weird way.
yeah,
Like,
it's like
yeah.
that's data.
Sure.
Like it sometimes you can make it like oil. Other times you can make it like a lighthouse, which is like a public good
Hmm.
that makes it so ships don't crash. And you can put it at the right point that encourages very specific trade routes to occur and economic activity to occur. And so you influence the world by putting it out there. And because it's a public good that can't be gated, it became a that was something governments did, and you could make the same argument.
Right.
And then you can also find metaphors for like data being, you know, countless other metaphors as you can kind of run into. But
Yeah.
I do think when you put a data product in the world, uh, getting towards the definition of what this podcast is, a great data product
Yes. Oh yeah.
creates an ecosystem around itself. I think
Yeah.
is the way I would say it. And I would say like perhaps, and this can happen intentionally, it can also happen accidentally. And
Yeah.
so by way of kicking this off, like I almost want to pose to you um what I think is the best data product ever created.
Let's
Um
go.
or one of them. The Enron email data set.
Ah.
Are you familiar with this one?
I am because so just flashback here when I joined AWS in 2014 to build the open data program there. AWS already had this thing called the public data sets program,
Yes.
which was that sort of preceded me. That was not, AWS had already been dabbling in sharing open data, but there was no kind of like program around it. And this program was somewhat abandoned. And, but how it had been set up was using elastic block storage volumes. So this is data that to access it, you had to turn on EC2. You had to turn on a server and then attach one of these volumes to that server, then you could access it. But we had all these EBS snapshots, these volumes of data that you could load up, and there was like one of them was the Enron email database, but some other funny ones. There was like a cannabis genome, like maybe the Marvel Cinematic Universe. There's something to do with like it was like a graph database of like Marvel characters or something like that, and some Japanese census data that someone found, and it was kind of this fascinating snapshot. I'm sure there's plenty of like Internet Archive screenshots of the site. It was just sort of like, here's some random data that engineers at AWS found circa 2012.
Yeah.
But yeah, the Enron database was in there. So go on. Let's talk about it.
Well, I just think Enron email database. So for those of you who aren't familiar with the Enron
Yeah.
email database, so Enron was a company that blew up. It in spectacular fashion. When did it blow up? Like 2001, 2002?
Yeah, and you're talking blow up pejoratively, like it was
Yes.
like catastrophic. Yeah.
Yes, it wasn't.
And
It was not
yeah.
a physical, literal blow up. It was just a
Yeah.
mountain of fraud,
Yeah.
and when the case kind of there was a ton of public anger. A lot of people lost their pensions. A lot of people
Yeah.
lost their stock, and effectively it went to zero and gets taken over. And it was a big company. In 2003, as part of the court proceedings, I think it was the Energy Regulation Commission released the emails from about 150 senior Enron executives. So this is about 1.6 million emails that get released, and this is 2003. Keep in mind, so like that is an amount of emails that would be out of reach for most people because
Yeah.
it's just incredibly hard to download. Though putting it in AWS I'm sure was very popular. If you search Enron email data set, map reduce, you will find hundreds and hundreds and hundreds of tutorials. And so it became this incredibly popular data set
Yeah.
that people wrote papers about
Yeah.
internal dynamics of workplace culture and language. I think at one point there were like 30,000 papers a year that were citing this. And when I checked Google Scholar, it maxed out. It was over 100K. Then you start to look at the companies that were booted up around it. I know multiple startups who started building email software or enterprise SaaS software that would start with the Enron email data set. You would start with it to kind of
Yeah.
build your products around it because there was no email data set. Like even
Yeah.
today, like you see it used in AI evals and pipelines.
Interesting.
Is just this. It's the only large email data set that is friendly, license, free to use, and it is generated an immense. I think it would be a very fun study for someone to do would be to calculate what the economic benefits of this email release from this absolutely failed company, and how
Yeah.
much it generated from this. And so, like to me, that has the qualities of a great data product, which is it
Yeah.
provides data that wasn't existed anywhere else.
Yeah.
It doesn't. So there was no competing offering, and any competing offering was just a minuscule amount. Two, it
Yeah.
has legs. We are, I want to say 22 years since the release, and it remains as relevant as ever. It was freely available and accessible and easy to work with despite its size. It was a very common map reduce demo, as I said, which would be the first step you would do in kind of dealing with it.
Yeah.
And it created an ecosystem around it, which I think is the biggest test case for a good
Right.
data is, do things grow out of it? And so it's kind of like, I was at the Monterey Bay Aquarium this weekend, and they had an exhibit on whale falls, when a whale dies and it goes to the bottom and it starts to decompose, and all of the like critters and everything come to eat it. And it's this like feasting moment. And that is the Enron email data set was the
Yeah.
equivalent of a whale fall.
Very juicy. I mean,
Yeah.
yeah. So much material in there. No, I love this. I mean, you're making me think about I have this white paper that'll come out eventually. I've been working on it for way too long. I may have mentioned this to you, but it's called Emergent Standards, where I make the case that the web is an engine for people to come up with new standards. Like, and so basically like the way, like the server client dynamic of the web is that like, if you have a server and a client that can talk to each other in a way
Yeah.
that makes sense to one another, it works. And like, it's worked with HTML. And then, we've figured out other ways to send more and more complex things over it. Including like, and what I talk about in the paper is like RSS. Like we want to figure out how do we syndicate stuff to one another. Stack catalogs. What's the other one? GTFS, which is the general transit feed specification. But basically, like what people don't understand, or like what a lot of people in policy don't understand, is that this is an emergent thing that happens as communities grow around types of data. So I'm agreeing with you, but like one conclusion I try to sort of like land on with that this white paper is that this is effectively like language. If it's useful to people, it will be adopted, right? And so
Yeah.
to your point about this collection of emails, it's practically useful in a way to a lot of people, and so people have adopted it, and it's become a thing.
Yeah, and I think the other
Yeah,
thing too is like it's so much easier to create that standard or have a successful data set if you're operating in the white space where it doesn't exist. Like
yeah,
so I work on the Overture Maps Foundation, as you know, and like that's a little bit of hard mode because you're competing with a lot, trying to establish a standard um,
yeah,
with where standards exist to some degree. Like OpenStreetMap
yeah,
is really built more to be a map rather than a data set. So it doesn't have great data standards for
right,
like easy data usage. It's starting to adopt a lot of the moves that we've made at Overture. But at the same time, it exists, it provides an alternative. And so it means we have to be that much better. Whereas with the
right.
Enron data set, like there's still no replacement for it. I was just looking at
Hmm.
the pile. The pile is a big data
Right,
set that's about, what is it? It's about 900 gigabytes was used to train Llama. It's used to train lots of open agents. We can assume it's being used to train closed agents, closed models as well.
yep,
Again, it's what 900 gigabytes, and the Enron emails are still in there. They're
yeah,
still like one of like 25 sources. There
amazing.
is no better email data set. So like operating in the white space means you get more rain to create those standards you go through.
Right, interesting. Um, Give me one interlude here. We got some technical difficulties. We got to make sure the YouTube live stream is working, or the chat is working. It's apparently
Oh,
disabled, but I'm gonna do a thing. Hey everybody! I mean, there are people on YouTube. I'm gonna click on something, and I don't know what's gonna happen. Um, oh, now I'm like delayed. I'm watching myself on YouTube with the delay. So hang on. Okay, I think it works.
you got it.
I think so. All right. Now, how do I get out of here?
I mean, look, you got your
All
first
right.
episode here.
We did it. No, we're good. We're good. I
Nice.
can see like all my friends. It's like, this is so great. This is like Romper Room. Like, I don't know if you ever watched that. It's like a show and I was like really
Yeah, you
little
got
and
it. You
it's
can
like,
wave goodbye to them, and you
yeah,
can't
it's
hear
like,
us
I see
back.
Alex and Camilla and Linda. This is good. Okay. So we're good. Um, so hold on. I want to talk more about the white space though. Define it more. You're just saying like creating an entirely new kind of data product or working in an
Yeah, well,
entirely
I mean,
new
I just
domain.
think there are some things where it's like it's I think you see this a lot in culture and technology too, which is like if you're the first to come out, you have a longer shelf life than your if than the best, which may come out later technically.
Right.
And so you have more ability to shape the standard, which is hard and a lot of pressure because you can sit there and think about it forever, or you can just release it and then evolve it quickly as they come. But it's hard when it's a
Right.
data set because you release it and then it ceases. It's the whale fall moment. You don't get to
Yeah.
go back and rebuild the whale and then drop it again.
Yeah. Um, no, well, and this goes back to like what I was saying about like the Nobel Prize challenge of like what are the economics of data? And I think you know this under working at Overture, it is expensive to produce good data.
It's very
Um,
expensive.
I,
It's
I cut
expensive
my
to
teeth.
maintain good data too. I think like one of the
Yeah,
things that like allow for longevity of these data sets are things where you don't need that timeliness. Like it's
right,
okay that the people in the Enron email data set are not still emailing and we aren't still capturing those emails for the last 23 years because that's not the function of that data set.
right,
It is a demonstration of how people use email rather than, and there's been no competitor. Whereas if
right.
someone came out and said, I'm going to make a business of selling select email so people can see it, like say, but there's so where we aren't going to see that, but we do see it in other spaces.
Yeah. Well, yeah, let's talk about this for a little bit. Like with the shape of a data product, they can take on many shapes, right? So my first job out of grad school, so like, my life story is I studied foreign policy. I got a master's in foreign policy, thought I was going to like work for the State Department. I
Yeah.
wanted to be a diplomat. But I was like, because I grew up in DC, it had no appeal to me. Like it had no luster to it. So I was like, actually, I just want to work on the internet. Like I had what I call like a coming out process in 2006 where I was like, I care about the internet, like, and I don't care who knows. Like, this is just who I am. And worked. So I took a job as a marketing enthusiast at eventful.com, which is like a Web 2.0 company.
Well, I mean, look, that's a title that comes in the Web 2.0 era.
It's true.
Marketing enthusiast.
Yeah,
That was a special time for titles.
It's like not a ninja, like definitely
Not a
like
rock
a
star, not
amateur.
a ninja. Yeah.
Yeah.
Just an
Um,
enthusiast.
just an enthusiast, but it was my foot in the door, and it ultimately I think was a very good decision. But what Eventful did, there's a site called Eventful that was like they gathered all the world's events data that they could find by scraping websites and getting access to feeds, and then standardizing it and making it available via an API. And what we learned very painfully was like this is very expensive, and the bulk of our database becomes useless every day.
Yeah.
Like,
No,
yeah,
exactly. That's like
yeah,
the opposite, which is like it's event data. It's
hmm,
just gone. It's done.
yeah,
And I think you see other people who have to struggle with this as well and try to figure it out, which was like, um, I think satellite imagery providers. You and I know many cases where like there's several satellite imagery companies who are like trying to figure out how to build a product that makes their old data valuable.
yeah,
Because right now, most satellite imagery providers are their stuff's valuable because it gives you that snapshot of what's going on right now.
yeah,
But they want to figure out everything else. And like you're not going to crack that at Eventful. You're not going to crack that at, anything that is, temporal in nature.
yeah, yeah. Well, and actually, so this is actually very timely. This Antoine on the chat, I love
Yeah.
this, is asking like, what about Freebase? This is the issue. It's like, what about Eventful? Like, Eventful never pretended to be an open data resource. It was doing the hard work of taking a lot of
Yeah.
open data or data that was like small enough that it didn't feel like we were just ripping people off, because also we were like highlighting events that people wanted to highlight, but then assembling it into a white pages like product where it's a huge compendium where the product is like we have everything in one place and then we sell access to it. Long story short, I don't think Eventful exists anymore.
No, it doesn't.
That the problem it's solved has been solved in other ways, and whatever. Events are still kind of a difficult space to aggregate in. But so Freebase, awesome example of around the same era. I think it was started in, hang on, I just looked up the Wikipedia page. It was launched in 2007. 2007, for what it's worth, the year that AWS announces its first service and the year that the iPhone is announced. It's like a very consequential year. Very heady days of Web 2.0, like seeing
Yeah.
what the internet can become. And so,
Succeeded according to the Wikipedia by Wikidata.
yeah. So there's room for this. Wikidata, I think people like it. It seems good in some ways. I've never really relied on it very much, but
Well, Wikidata is a good example of like the importance of data UX, which is
right.
one of the things that was so nice about Freebase was it was this. It's kind of what Overture tries to do with like its GERS identifiers, which is for everything
Yeah.
there would be an entity that you could then walk. So like, here's an entity for JED. Now we
Right.
can find everything JED has open to it. And yeah, I think Wikidata is kind of sneakily one of the best crosswalks on the web. I think they track over 800 different crosswalk kind of identifiers, like Apple Maps ID, Google Maps ID, a lot of federal IDs and everything else. And it is fairly successful. It's API. Like I think there is a little learning curve for that.
Yeah.
I think also when trying to build products off that, it's incredibly good for crosswalking data, though oftentimes you have to do a little bit of hurdles to get the data down for that crosswalk. But
Yeah.
again, that's like a whale fall. Like again, it's the same thing, which is like once Google walked away, it's nice because it allowed for Wikidata to exist
Yeah.
in a way and utilize the Freebase data. um, as its code, but then it had to kind of supply the revenue, or at least the donation model to keep it going.
Right. And it's just all goes back to the fact like this is expensive and hard. And
Yes.
what I, these days, the year 2025, there's a lot of concern about sources of data that had long thought were kind of like unimpeachable and were going to be reliable, provided by governments. And that's just no longer a safe assumption to make. And I've actually been a voice, shouting into the void for years. Like this was never a safe assumption to make. That we need
Yeah.
to think a lot harder about this kind of infrastructure because it's hard, it's expensive to produce. And if we could figure out the economics of it and have better markets for data, I think we would have more data. The One of the hard things to grapple with here, though, is that like nothing is free. And what you were saying before about the difference between like a fishery and
Yeah.
and a data set is that like there's this phenomenon that I chalk this up to what's called nanoeconomics, which is like the economics of like individual, like very small transactions. And so if you examine like voting behavior, people are like, my vote, like, how could it possibly count? It doesn't matter.
Yeah.
But like votes do matter, right? And like we don't perceive the emissions that we create by living our lives, but like they obviously add up. And so same thing, like Wikipedia, it feels free to open up an article on Wikipedia, kind of to all involved. Like Wikipedia itself doesn't really register one page load, and it certainly seems free to you. But Jimmy Wales is going to ask you; he's going to nag you to donate.
Yeah,
People need money. Like,
and I think there's also
yeah,
the flip side to that as well, which is something that we see. So when the advertising ecosystem was the way you monetize data,
yeah,
I'm sure many people talk to you about like the dream that everybody wanted to figure out is how can I've solved the privacy problem in advertising. I'm
yeah,
going to create a system where people can opt in to share their data and they get paid for it. I know countless companies or
yeah.
people who dreamed of trying to figure this out because they're like, look, people get real value when they sell their data. The advertising ecosystem is incredibly huge. The problem is that your data on its own is worth nothing.
Nothing. Yeah, exactly.
Absolutely nothing. And it's worth something in aggregate, but nothing in by itself. And so people would make runs at this, which is like, oh, we're a co-op, we get to brand together. You like try to get some maybe economic innovation of like, okay, have a longer timeline, take advantage of compounded interest, all these other things. But it's kind of the same thing, which is your usage of Wikipedia is a rounding error, but it's expensive.
Right.
But the value of the data you create is a rounding error. And we saw this during the ad
Right.
era, and we're seeing it again. There was what's the mobile phone network that launched a couple days ago, where it's like we get training data on all your calls, and so you get cheaper voicemail or cheaper phone
Whoa.
service.
I didn't know about this one. Oh, fascinating.
Yes.
Tons of people are going to sign up for that.
I don't think, but again, like I haven't looked at the cost. It can't be high.
Yeah.
Like
right.
how much of a discount can it actually apply?
Yeah.
I'm looking it up because I want to see. I just saw it because it's way easier for someone like Meta or Google to just give you the service,
Right.
and the service is predicated on sharing data.
That's right.
But we will just never see that go away.
No, because in aggregate, it's just too powerful, too seductive, and
And now
really
we're
seeing
seeing it. But now we're seeing it like the flip side of this is the Anthropic case right now, which is how much per book was that settlement? Was like $3,000 per book, which is like fairly. If you're an author, $3,000 for a book, like for a lot of authors, it's going to be a lot. For a lot of authors, it is not going to be.
Yeah.
But it is more than you would expect, and they're going back to the well because the judge took away the settlement, and so we'll see where that does net out. I do think like trying to figure out the cost in training is hard. I don't know if that's something like the idea of opting into training. I think is like you're going to get applications that rise up too quickly that are just going to take your training data. So ChatGPT, Anthropic just asked everybody to re-opt in, change their privacy,
Oh,
because
interesting.
they're going to be training on that. Meta always has, always will. Um, uh, and so how are you going to create an ecosystem to pay people within that? They're just going to go use these services,
Right.
and kind of knock it out.
Yeah.
So I don't know.
Amazing. Okay. Well, let's shift to your blog post now then, because let's talk about large language models. We're talking about Anthropic, and the basis of these things. So you in your blog post, which highly recommend, it's in the whatever we link to it when people registered for the
Let's
thing.
figure it out.
You can put it in the chat. But great overview of these 3 data products, and again, this is another sort of chance for us to talk about what is a data product. So let's start with the beginning and talk about MNIST.
Yeah. So
Yeah.
one of the reasons I think large language models and AI in general are the fulfillment of data is the new oil is because previously, if you wanted to write a computer program, you had to worry or make a computer program. You really had to worry about 3 things. You had to worry about your software and your hardware. Actually, 2 things really. That's it.
Yeah.
Just write my software, run it on hardware. I'm done. With machine learning, deep learning, and now what we call AI and all those subsets of it, you have to have software, hardware, and then data. The data bit is non-negotiable. You need the data, because the way machine learning and deep learning works is rather than having the programmer write the rules for what the program does, you give a sufficient volume of data and present it to a computer and a computer program for making machine learning or deep learning models, and you give it instructions and you ask it to interpret the patterns in the data without and figure it out for itself.
Right.
And within deep learning, this is even another layer on top of that, which is you figure it out without even telling what to pay attention to. You aren't labeling it, you aren't telling it. It's just here's a pile of data, go find the patterns. Now, in the early days, there wasn't a lot of data because think about it this way, which is if you were an early adopter of computers, let's say to 1994 in this case, you would go to the computer store, you buy your computer, you bring it home, you plug it in, and that was that. If you got any data into your computer, it was because you typed it out or you inserted a floppy disk that you got in the mail or picked up at the store, maybe a CD-ROM if you were real fancy. Um, that's it. The bottom, there was no internet connection, there was no downloading. So, like, to acquire data was an incredible exercise. And so, as a result, could you build machine learning systems? Not really. You had to have this access to data that you just weren't going to get. So, people didn't do that. And so, it wasn't a field, it wasn't a thing. Like, people are going to say, oh, neural networks were back in the 70s. And it's true, but there weren't many who could play with it because the access to the data was so limited. Um, and then what we found, though, is that, and this gets back to the white space, which is really any data that was delivered to your door was brand new data. There was no competition for it. Like, I don't know about you, but like, I mean, like you'd get maybe a CD-ROM in your magazine, or like what would you get for data? Like, what was the consistency of data? I think the only thing you would have is like maybe some Project Gutenberg floppy disks you would pass around, maybe some like Encyclopedia Britannica CD-ROMs you would pull out, but there
Right.
wasn't kind of a world of data. And in this environment is the first data set we're going to talk about, because we're going to explain kind of the history of AI in 3 data sets. And the first data set is the MNIST data set, the MNIST data set. Now, this data set, now it's on Hugging Face, as you can see.
Yeah.
You can install the Hugging Face datasets pip library and download it. And it's also bundled with almost every machine learning library. So if you install TensorFlow or Keras or whatever the backend, and then you say like install MNIST, it's almost certainly there because it is the data set that is the effective hello world of machine learning. because back in 2004 or 1994, even longer. So what is MNIST? MNIST is a collection of 28 by 28 pixel images squared, and they are handwritten letters. Actually, no, it's digits. It's not even
It's
letters.
just digits. Yeah, it's
Just
just
digits.
numbers. Yeah.
Just numbers and digits. They collect these from two sources. One of them from, I think, census employees, and then the other one was from a high school class. So like this is
Yeah.
like a classic case of just like someone had access to two people. They were getting values out of them. They're writing down numbers either as filling out forms, filling out tests, and just someone
Yeah.
in the right position is like, oh, this could be useful. We're scanning these anyway. And so
Yeah.
they took some time. We don't really know how this happened. They basically realized, hey, let's make a data set of handwritten digits. They didn't put a lot of thought into it, or how it might be used for machine learning. Like one of the issues is, so when you're building machine learning systems, you have a test and a train subset, and you should never mix the data. So
Right.
your train is what you build your model on. You train, you learn from this, and
Right.
then you test the quality of the model in your test data set. In the initial distribution, one of those data sets was like the high schoolers, and then one of them was the census people, which is a terrible way. You should have it all mixed up and scrambled, because
Right.
you can make some assumptions that the census people may have different handwriting than a bunch of teenagers that have had no training. And so later they improve this, but again, they put no thought into this. This is
Right.
the equivalent, and they decided to distribute it. But like distributing was like literally like CD-ROMs, burn
Yeah.
CD-ROMs. You would get it in the mail. You would get, it's like you'd have to like order it.
Yeah.
Um, and this was the NIST data set, the first one.
Yeah. So, and again, I think we need to maybe tell people like what NIST is. It's the National something something
Institute of
National
Standards and Technology.
Yeah. Yeah. So
So
it's a
the
government
type of
agency.
people who would
Yeah.
be looking at pictures of numbers, and they're the type of people who thinks there's something here.
Yeah.
Did you ever watch the movie Ed Wood? One of my favorite movies. Great movie.
No, I really
You
should.
should watch Ed Wood. But there's a
Okay.
scene in the beginning where he's like on the studio lot. So Ed Wood is famous as like the worst movie director of all time.
Right.
And he's walking the studio lot, and he's walks into someone's office, and they're reviewing the new stock video they just shot, or stock film they just shot, which they just keep in the studio library to like insert into movies later. And he's just watching like disconnected random scenes, and he's like, man, you could make a whole movie out of this. Just like highlighting how bad his taste is, but at the same time looking at pictures of numbers and saying we have something here, is something you expect from the Bureau of Standards and Technology. So they put it on CD-ROMs and mailed them out, and one of the people they mailed them out was a computer programmer at Bell Labs, back when Bell Labs was still like the institutional research standard. And the guy who got it there was Jan LeCun, who is one of the godfathers of neural networking, one of the AI leaders at Meta, led kind of Llama and other things. He just released the world model last week. He's just kind of a godfather of this stuff. And he had been working on the problem of trying to recognize numbers, because they worked at Bell Labs. This is something they would want to do, is they had to automate and kind of figure out and look at mail, look at zip codes. That was all it was trying to do, is like, can we look at a camera and look at zip codes and automate the entire thing? And so using MNIST, he trained a neural network, one of the first neural networks, and could basically delivered a watershed moment in accuracy. Like the error rate now is down to 0.8. He modified NNIST, mixed up the sample sets so it wasn't just high schoolers and census. It became the hello world. And at its peak, AT&T was using this original neural network software to read more than 10% of all the checks deposited in the US, which was then software that gets sold by Bell Labs. You will find this in almost every machine learning textbook, every deep learning textbook. And part of it was just, it was staged, because once Jan got it, he reformatted the data and this is touching on the question someone just asked, specifically for his task of training neural networks, which is why
Right.
this data set is so valuable and why it's become this hello world, is that you can do a one-line install for MNIST data and it's ready for you to use. It's segmented into the different data sets. It's all standardized. The levels of contrast and anti-aliasing, the flipping, reversals, all of those things are all ready for it to be used. And it has kind of survived this test of time and enabled the foundation of the very first neural networks. Again, this is a data set that was distributed on CD-ROM. It was
Yeah.
sneakernet. It was mail. And it, I would argue, birthed what would later become our deep learning ecosystem that would lead to AI.
Yeah. I think, no, I mean, and this guy, I got to pull it up because I got to get his name right. Donahoe, this guy at Harvard, or sorry, at Stanford,
Donna.
David Donahoe. So wrote this paper that I still have not finished. It's very long. I'm putting it in the chat, but like Donahoe's a smart guy, but the title is a little clickbaity for my tastes. It's Data Science at the Singularity. Not a terrible title though. I mean, I think he makes the case like there's something going on here, but he credits LeCun as the godfather. You'd agree completely with what you just said. And the gist of what Donahoe says in this paper is that the machine learning has made the enormous strides it has because its community has adopted a practice of frictionless reproducibility. So one of these fantastic phrases, similar to undifferentiated heavy lifting, that's like impossible to say, but very useful. But this idea of frictionless reproducibility within the machine learning space, where people have been able to share these great data products, compete around them, going back to your point about a great data product has a community around it, have leaderboards, and it's just been like to the moon. And this is a sort of tease up Alex's question in the chat, like how would we get, for example, environmental data to be seen by AI models? How do we do that? My answer would be, and this is defending everything that we do with this podcast and also with Source Cooperative, is we would improve access to great data products. Like we would.
Well, I think there's two steps, which is cheating ahead. But there's a couple things that come into it, which is this idea of reproducibility, though. That was great in machine learning and deep learning. It's really hard now. I mean, Mira Murati, like she left OpenAI and founded Thinking Machines Lab, her own lab, one of the many OpenAI people who have left to find it. And right now they're focused on reproducibility because it's near impossible because of the probabilistic software and the way inference works at test time. And so like it's almost impossible now, and they're like innovating on that sense. But the other thing I would say too is we'll get to this, but I think the other interesting thing is benchmarks.
Yes.
Which is you don't just need to put the data out there. You need to define the problem and provide the means for testing against it. And so like if you want to say, oh, it's not enough to get seen by AI models, because guess what? They don't care. They're just going to go suck everything else. Right. What you need to worry about is that the people building them have a benchmark to build against. That now it's when a metric or something becomes a metric, it becomes the
metrics become targets.
Exactly.
I mean, yeah.
And that's what it is, which is like, and this gets back to, I would even say, my funding. It's not enough to just be there. You have to challenge these things and provide a mechanism for measuring success. If you don't do that, no one's going to care about it.
Yeah.
But yeah, so that's Jan LeCun. He's doing his thing with CD-ROMs, sending it out, and like it's crazy to think like part of what the internet has done and broadband and like is it speeds everything up because it makes exchange so much easier. And yes, the test benchmarks need to be actually relevant to the use cases. Yes. The thing about benchmarks is that they are shipped by people who care about specific things. If you're shipping a benchmark and you don't have an understanding for why it's important and why you care about it and you have some stake in what that is, you're wasting your time. Like, why are you shipping a benchmark in the first place? The point of putting the benchmark out there is to challenge people to perform against the thing that you care about. And there's lots of great examples of that.
Actually, can you help educate me on something I'm like very naive about? And this is
Sure.
embarrassing, but I'm just going to be vulnerable on this podcast. Is so to Tyler's point, there's been my understanding. There's a lot of discussion about benchmarking with like Earth observation AI models and stuff like that. And a gripe is that you can benchmark these things based on some sort of like you can create like a technical benchmark or something like that, but it is divorced from reality, like from like what's actually happening on the ground. And it's basically it's like you can run a model and then test it to see if it's performed in a certain way
Yes.
that like indicates that it's a good model, but
Yes.
that does not indicate if it's actually useful. Can you
Well,
explain this
I
to me a little bit
disagree
more?
with that. I mean, I think there's lots of ways you can game benchmarks,
Yeah.
but here's the best way to think about benchmarks, in my opinion, is that they are an encapsulation of knowledge with an opinion that allows you to test your performance against that encapsulation of knowledge. Um, is yeah, we'll talk about overfitting in a second, Joey. That's is very much a thing. But the thing that I have that's a problem is like a lot of people in earth sciences or sciences in general is they go to like big private companies and say my
Yeah.
thing is really important, you need to build against it. And that is first off, you have to get them to believe your thing is important.
Right.
And then B, they have to get up and running and understand that space really, 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 really well. And then they have to C, build against it and follow it to create this own benchmark
Right.
and have this thing. Is that so when you create a benchmark, you are doing that work for them. And when you do that work for them, you get to encode the things you care about. It comes
Right.
back to the like there's a I think it's Louis Pasteur quote, which is
Okay.
give me a laboratory and I will move the world. And he was talking about it in the case of like being able to freeze benchmarks and maintain science, or freeze a variable and maintain science. And so
Right.
if you can create a benchmark, you are creating the eval reality that you are asking that model to be held against.
Yeah.
And this happens for lots of things. And so I think right now, the two most successful benchmarks are the ARC AGI benchmark, which
Okay.
Francois Cholet built, which is, again, he basically said everybody's talking about AGI, but it's not in reasoning. It's really just fact memorization and repetition. He
Okay.
has a different thing, which is like all about pattern recognition. It should be incredibly easy for a human to do, but incredibly hard for a model to do. And so that has been kind of the thing. Has been in the deep learning space for over a decade. He is a leading voice. He created this, and all of a sudden, it became the thing that everyone starts to brag about when they get this because it's really hard. When OpenAI's O1 was the first one to do it even somewhat passably, it was a really big deal. And ever since, like, we're still kind of chasing it. So, like, both his design, his leadership, his brand helped set that as this big thing. The other
Yeah.
more tangible example of like you don't have to be a leader in the space, but you just found the white space is a benchmark called Terminal Bench.
Hmm.
So Terminal Bench is how do you testing a model's ability to use the terminal, use tools in the terminal. So with coding agents, this is
Hmm.
so important.
Yeah.
Why do I care about having MCPs? Why do I care about having all these crazy tool sets? Just teach the model how to use the terminal and all the problems are solved.
Right.
And this was put out by a really great team. And they designed it in a specific way to basically get the agents they want. They spent a lot of time on this. This is out of Stanford and funded by Laud. And this has now become the thing that people get against. So, like Anthropic, if you look at when their models come out, they will always put the terminal benchmark as like their top thing. When they bumped Claude Opus from 4 to 4.1, the main thing they cited was their terminal bench improvement. So that's a good example of like, I'm creating the package of the reality I want from this. So
Yeah.
someone in the chat replied to your Earth observation benchmark, which is like, all right, benchmarks are great, but my gripe is that most Earth observation benchmarks, so it's looking at satellite imagery, they're focused on object detection.
Right.
Very few are focused on temporal signatures of change. Well, what that says to me, Tyler, is that's an opportunity for you to create a benchmark, or for someone to create a benchmark to measure this capability that you want to build into this model. A benchmark is a data product. It is honed, and I think it's kind of the current way that data products are released, or one of the main form factors they can take in this model. Yes, you have a worry about overfitting. The SWE bench, SWE bench, is the software engineering bench. It is again, it was one of the biggest one first to market, which is, can a model take Google issues and submit changes and submit PRs that pass? And it was adopted quickly as the main thing people were building against. I talk to AI researchers at foundation model companies, and they're like, I'm just trying to get another point in SWE-bench. That is what keeps me up every single day. But again, it has its own shortcomings. Like 50% of SWE-bench is just the Python Django library. Like, so it's really good at building the Django library,
Right.
but maybe not very good at some Rust, or maybe not very good at, some data pipeline you're building. So again, these things shape the outcomes, and communities grow up and private companies grow up. And so that's kind of why I think benchmarks are kind of a modern data product.
Interesting. Okay. There's a lot to think about. I'm looking at the clock. I want to, boy, where are we going?
Yeah.
I want to talk about Common Crawl, but I also
Sure.
like we did not specify an end time for this, because like good
I have a hard
podcasts
stop,
just
but
go off
yes.
the rails. Oh, did you have a hard stop at the top of the hour?
Yes.
Oh, then
At
okay.
not our top of the hour at 1.
Okay.
Yeah, we got an hour and 10.
Oh yeah. So we booked our own time. So for those listening, we've blocked our calendar for 2 hours, so we can go this long. We're gonna go for as long as we want, but no further than 1 p.m. Pacific.
But I think the benchmark thing, that's how we talk about it today.
Yes.
But transitioning from MNIST, we went to ImageNet.
Yes.
And that is something that Fei Li created when starting at Princeton, because she built it as that challenge. She saw that there was WordNet, which was out there, which was essentially a natural language processing training data set. And she said, well, I want this for ImageNet because I want people to build better image recognition models. And so to do that, she realized they needed a way to test it and train it. And it became not only a thing you could train models on to improve the software, but it also became like the foundational improvements of kind of deep learning in general. Was, again, you put out your challenge and you make people go to it. It was a benchmark as much of a data set.
Well, right. And like built in somehow, I don't know how she did this in terms of like funding and her stature at Stanford or whatever, like challenges. It was just sort of like, this is a data product, that we're putting out there, and we're going to run challenges. And it was not, this is one of these overnight successes that took something like 6 years or something like that. I don't know, like when.
It was a long time. And
it was a long time before AlexNet came out.
Yeah. And I think the other thing too is like they had to create it. Like the only way they were able, so MNIST came out on a CD-ROM pre-internet.
Right.
ImageNet could only have been created after the internet existed, because they leveraged Mechanical Turk. They leveraged Google image search. They basically were just paying to label images, and the price they just would not have. So, I think there was a couple years that, because ImageNet was it was after Common Crawl first launched, but its breakout moment came before Common Crawl's breakout moment occurred. And so AlexNet was 2012, whereas ImageNet was like, I think 2008, 2007.
Okay. Yeah.
But yeah. And so go ahead.
ImageNet's another interesting example though of well, this is when I said I wanted to talk about licenses, because when I was at AWS, people were like, hey, you should host ImageNet in the open data program. And I'm like, I mean, sure. Like, I think that would be cool if we did. Also, like, people can get it. Like, you didn't need S3 necessarily to get ImageNet. Like, you could download it. Like, it wasn't like so huge that it mattered so much. But I was also like, look, my lawyers aren't going to like this. Like, if we're going to host these images, um,
Peeled
we
off
don't
of
know.
Google search.
Yeah, they're just like random licenses all over the place, but it just reveals just how brittle this sort of like licensing regime is for this sort of stuff. Where it's like, look, who's going to sue you honestly because you're using some like 120 by 120 pixels square picture of like a dog.
Yeah, I mean, I do.
Know?
I like it
Like,
is that weird thing where it's like it's fine to bootstrap it, but if
yeah,
like you're really successful, someone comes knocking. It's kind of
yeah,
like you know, Google looks the other way on people using Street View images, even though they know that they are being crawled in some way or another.
yeah, yeah. No, and I mean, or come for Anthropic once they've raised enormous amounts of money, and they'll be like, sure, great. Actually, like it's an honor to pay this because we know that no one can come up behind us now.
Yeah.
It's like, because we have got the cash.
And that's what you're paying for. I mean, that some would argue that's why Google bought YouTube was purely to buy the court case, or one of the main reasons. But yeah, so
yeah,
that was ImageNet was
okay.
basically a database of I think about 1.4 million images,
Something like
that were labeled 1,000 categories, 1.4 million images, and then just said, hey, every year we're going to hold a contest to see who can get the best one. Now the idea of waiting every year is a positively quaint notion. People just download and run the benchmarks every single day. You have to upload it, the whole thing. But I do think like ImageNet was every year, and so that went around for a while. Side note,
okay.
go ahead.
There you go.
Side note, I was thinking about this last night. So in a former life, I was a media strategist at a large media buying company. And in 2009, I was writing media strategy for NVIDIA. And I was thinking about this last night because NVIDIA had a new technology that they were very excited about called CUDA. And I remember going down to the briefing and they're like, here's what we're going to show at the floor at our next big conference. Here's all the demos for CUDA. CUDA is this idea of we can use GPUs for generic computing and we can use it for immense parallel processing. We think this is going to be really big. And we would ask, all right, well, what are people going to use it for? And they had like 8 demos. None of them were machine or deep learning. There was a couple biotech ones about like protein folding or what have you. There was a lot of cloth simulators. They're like, hey, we can sell this to fashion designers to simulate, how a cloth is going to drape over someone. They just had like tons of different things, and they had no idea what they were going to use CUDA for. They just knew it was going to be this big thing, but they had no idea. And so and you could make a very strong argument that like CUDA is the reason NVIDIA is in the position it is today, being one of the most valuable companies in the world. And they had no idea what it was for. And so CUDA came out 2008. I worked on it in 2009. And it was still this thing, like no one knew. You would go around and like they just would look at you and they're like, well, we can do these things. And you're like, it's kind of interesting. And it wasn't until 2012 where they kind of had the first glimpse. So like we're hitting the big names here. Geoffrey Hinton, who did win a Nobel Prize for deep learning and machine learning. Ilya Sutskever, who later would found OpenAI. Alex I can never pronounce his last name, Krzyzewski. They built AlexNet,
right,
which basically performed against ImageNet with a score of 84.7. And you have to understand this was a 10-point plus difference compared to any previous competitor that year or before. And it was the first time that they had used deep learning accelerated by a GPU. And they were just using 2 consumer GPU cards. They were using like basically what you would buy to game at that time.
Yeah.
And that basically started deep learning. Deep learning was like how we talked about AI before AI. And so that was kind of what set it off. And I think the big step change here is that, again, this comes back to the benchmark thing, which is Fei Li created this space essentially out of a benchmark,
Yeah.
which is deep learning became a thing because its value was proven because someone built a data set and then people gamed to see how well they could perform against it. A
Yeah.
benchmark is essentially a data set with intent. And when you ship that out into the world, you get people to do things against it if you make it exciting, if you make it collaborative, and if you're
Yeah.
operating in the white space.
Yeah. This is I'm going back. Linda said something like she said data is typically purpose built. Understanding this will force us to examine our data more rigorously, creating a significant demand for data repurposing, especially with AI. What I'm hearing is like, or where this is coming together for me is that like you can produce a data product, and we're going to talk about Common Crawl next. I think we should, and then you have to produce benchmarks attendant to that data set or that data product, which are basically just any number of arbitrary goalposts that you want to set, and be like, because Common Crawl is so rich, obviously it can be used for so many things.
Yeah.
So you just need a benchmark for each of those things, and just say like, well, can you do this? Can you do that?
And if you, and I think some of the most interesting things out there are benchmarks. So like we talked about, Terminal Bench is one of my favorite examples. The other is the Berkeley function calling leaderboard, which is just like testing how well LLMs can use tools that are given to them for like agentic purposes. And it's really, really interesting. And then what's the other one that I really like? It's not Empathy Bench. What is it? It's there's another one. Sorry, John Hewitt. Sam Page has a great benchmark that is one of my EQ bench. And he maintains this himself. Just some dude, love his stuff. And he's like, I'm interested in having LLMs become a better writer. And again, it's like one of those things that's like really hard to quantify how to make it a better writer. So again, he's like, here's one metric. Here's another metric. One metric is like, how often do you reuse the same phrases? Okay, great.
Right.
That's great. We can't do this, but 2, like long form writing. Like it's like all of these, like, and it's a really interesting thing. And he admits, he's like, this isn't perfect. But again, you start to see people building against it. And it does start to influence and shape the arc of development.
Yeah. Well, let's talk about Common Crawl.
Oh yes,
a bit more in depth. But I got to shout out Sam Reddy at Common Crawl. She's like, hey, we have an event coming up. So people who are in the Bay Area at Stanford on October 22nd, there's an event called Preserving Humanity's Knowledge and Making It Accessible, addressing challenges of public web data. This is the kind of thing I would love to go to. I'm unfortunately booked at another event. Jan Zuckerberg Initiative, I think, whatever CZI stands for. I'm going to be at one of their open science event. But man, if I weren't with CZI, I would definitely be trying to go to this thing. So, and you can watch online. So I put the link in the chat, and we'll share this. I think we should share this podcast before October 22nd for sure. So shout out to Common Crawl. Drew, tell me all of your deepest thoughts and feelings about Common Crawl.
I mean, Common Crawl is novel story for how early it started, and that it wasn't really built with machine learning or AI in mind. It was so to give you some perspective, the Common Crawl project, which is essentially, it's like the idea is that, hey, we're going to scrape the internet and put it in one data file ready for people to use, so you don't have to go scrape it. Because again, we believe that, again, lots of people can build things if all of this is accessible. And so the net value out of it would be tremendous. It began in 2007, the same year that Fei Li launched ImageNet. And so Gil Elbaz, it was Gil, good old Gil, he started it. And he formed the Common Crawl Foundation to basically, and it's funny, he founded it as he left Google.
Yeah.
So it kind of tells you, what his motivations were, which is like, I want to build essentially, I don't want Google to get a lock on the internet. I want to kind of expose the thing that's really expensive to bootstrap and start up, especially in 2007, which is crawling and preparing all of the files. And now it's a single data set essentially with 250 billion web pages collected over nearly 18 years. And about 3 to 5 billion pages are added a month, though sadly, Common Crawl is getting shaped a little differently because its crawlers are getting blocked. And the reason its crawlers are getting
Yep.
blocked is because of AI driven crawling. So it's in a weird twist of fate. Common Crawl became one of the foundational things that early language models would train on. It would become a critical ingredient in the pile, Google's C4 data set,
Yeah.
basically subsequent data sets, kind of child data sets, which is like, hey, we're not going to include every single forum, or we're not going to include, duplicative data, or we're going to filter all this
Right.
stuff down to the high quality stuff. But then once you start building it, and this is where it gets into the data like oil, I use that. Let's say I use that to build my model that later becomes ChatGPT.
Yeah.
I have so much I'm not going to rely on Common Crawl anymore. I'm going to start building my own crawlers and go out to the things that I care about and do it with a much greater frequency so that I can improve my
Right.
model. You get enough of these, which you do. There are a lot of people out there hosting websites right now that are having to think about how to gate their content to prevent legitimate and gray market crawlers that are just hammering their sites. And so now, like, Common Crawl created this thing, but now we're kind of having a tragedy of the commons, which is everyone who grew up around it now sees running their own crawler as a competitive differentiation. And they're going out there and kind of doing that itself. All the while, Common Crawl is still going, but its kind of surface area is starting to shrink a little bit because different web pages are shutting off access to crawlers because of this mess that it has created. So I do think it's this closest thing that we have in data to a tragedy of the commons. But yeah, I'll pause right there before I talk about why the text is so important.
Yeah, no, I mean, I think it's an amazing story. Gil, I mean, has told me he's like, I'm pretty sure Common Crawl is like the most impactful nonprofit ever. There's definitely a case to be made there. I don't know exactly how you'd quantify that, but holy cow. Like,
I mean, because it's like
yeah,
everything grew up
yeah,
around it. And like,
yeah,
even like, you'll look and people will say, oh, so and so didn't use Common Crawl, but then you look at the data sets they did use and they were derived from Common Crawl. So it
yeah,
is this like it basically fueled the entire first wave of large language models, which is
yeah.
like what percentage of our GDP at this moment?
I think it's 140% of our
Yeah,
GDP. It's
140.
like something.
We don't know how that's possible, but it is. That's what
Yeah,
I'm saying.
yeah.
But
None of the math makes sense when you're hearing what people are talking
yeah,
about.
and this is like one of those weird things that, like, when he built this, like, one of the weird things about large language models is that everyone was kind of surprised when the first large language model like worked, like attention is all you need, because like it's this
Yeah,
thing where like previously you would have to put structured data into these deep learning models and then they would have to figure out the
right.
relationships. No one at the time, like when people thought of structured data, they thought of the work that like Fei Li put together with ImageNet, which is here's an image and here's some labels. And
Yeah,
so the big gate for deep learning is like anyone who wants to build on deep learning, they'd say, all right, well, where am I going to get that labeled data? Where am I going to get that structured data?
yeah,
With large language models, the thing that was shocking to everybody is like, oh, wait, language is structured because we can see the order of the words. Some words come before each other, who come before after, in all of these assemblages. And we don't need
yeah,
to label language because it's already organized and structured. We just have to have enough of it. That was the thing. The magic thing was that you built something
yeah.
big enough that it would display spooky, intelligent qualities. And that was what
It's
Common
wild.
Crawl enabled. Because if you didn't have
Yeah,
that, you couldn't test that randomly because you would have had to
right.
stand up your own crawlers before that. So like the fact that it just existed allowed for that discovery to be made, which is why I
Yeah,
think I wouldn't argue with Gil's claim.
yeah. No, it's incredible. I have other apocryphal stories. I mean, we hosted Common Crawl at my program at AWS is the home of Common Crawl. So um, I have stories that I probably shouldn't tell, so I won't. But like um, it's phenomenal and kind of insane. And I was joking about this last week at an event at Climate Week because I was in a room with a bunch of organizations. I'll just say like very large corporations, not a government in sight, talking about uh, sustainability data for global supply chains. I won't go into much more detail than that, but I said, look, you got to understand. Like, there's this story about this guy, this one dude, granted a billionaire, who's just like, here's a thing I'm going to do, and does it, and it has this huge impact. And I'm like, it's this heartwarming story of the impact that one billionaire can have on the world. But the point also being that like it is possible to create a data product that has a very consequential impact. Like, and if you feel like there's something there, there might be something there.
Yeah.
In Gil's case, I mean, my story, at least from what if I recall him explaining this to me, is that he creates AdSense. It's acquired by Google. He spends his time at Google, and he's like, there's got to be some kind of fail-safe for this kind of thing, and where we can't have one company that is like owns all of the world's information. There's some irony in the fact like of like what Anthropic and OpenAI are becoming is just sort of like the next version of that sort of thing. Um,
But
but
I
I'm not
mean,
mad about it.
I think about that a
Like,
lot, but like,
yeah,
I think it's interesting now we've gone from the crawl being the thing that's valuable to the interaction data. So like when they were talking about breaking up Google, like one of the
right,
things that they were talking about was like making the ranking data, like making the index open,
yeah,
which not isn't just the data, it's also the relationships that exist in the data. But again, like one of the things that I'm shocked about with LLMs, which I find to be like really interesting, is that like no one's running away with it. Um,
no,
like Sonnet 4.5 came out and said like, "Hey, this is the best model this week, the best coding model." And like, but the thing is like the difference between Sonnet 4.5, GPT-5, even like the open models, like the larger Quen coding models, like they might not be perfect, but like they're a lot closer than you'd think. And it's to the point where like everybody jumps on whatever the newest thing, but you could just be like sitting on like you could have been sitting on GPT 4.0 for a year and you would have been fine. Like, and I
yeah,
do think what's wild is that the floor is coming up faster than the ceiling. The ability of 7 billion parameter models to effectively double in quality every year is just absolutely insane. And so like you will get some things from like throughput and other things like that, but like
yeah.
I think the weird thing is that even if these guys win, you may end up having like free access to something running on your device.
It's
That would
incredible.
be it's bizarre
Yeah,
and it's really weird to think
yeah,
about.
it is. Well, let me I want to go back to the data is oil thing and how this like LLMs change this sort of stuff. And Alex left another comment about, people trying to use robots text or then there's like LLMs text to try to
Yeah.
influence how the bots can navigate the web.
Yeah.
So I have this theory, I'll just bounce it off of you. I don't know if it's a theory, but this idea that like so the internet has been full of like really amazing data for a very long time. And what a lot of us who've worked in open data have just been sort of like scratching our heads about. It's just like, well, why doesn't it get used? There's all these open data portals that don't get used. And one of my answers to that is that humans don't know how to use data by and large. Like
Yeah.
you just take a sample of like um, a million humans, you're going to get a very small percentage that actually like know how to do stuff with data.
Yeah.
And also like have time. I mean, this was always kind of the funny thing is an early realization for me when I was working in civic tech stuff was that there's people that are like, oh yeah, like we'll just open up our city's data and then these people will just like do cool stuff with it. And I'm like, hey, if someone knows how to do anything with your data, which is not that good, it's good. It's kind of a pain to work with. They have a job. like, you have a narrow window of like college kids and like civic sort of like tech activist people who before they like like
have children and
exactly
full-time
have
jobs.
kids. I was just say like get a wife or a
Yeah.
husband and have a job. Like they're willing to do that sort of stuff, and that's it. You know, and they just kind of go away after a while. But LLMs 24/7 can do stuff with data, and so we are at the point where I think that we might have created a market for data.
Yeah.
If we can get, and here's my crazy idea. Tell me if I'm crazy. Well, also, I think this is already happening, but like ChatGPT or the OpenAI and Anthropic should pay for data. Like they should just like, hey, they come to some data portal thing where it's like, hey, we maintain this data. If you're a bot, we're going to charge you a 10,000th of a penny per request here, so that you can.
Well, I mean, that's
it's
what
basically your research
Cloudflare is
budget.
trying to do.
Yeah, I think it's a good idea. I don't think Cloudflare. I think Source Cooperative should do it because we're not owned by anyone. But anyway.
Yeah, no, I think it's an interesting one. And the incentives are absolutely crazy to think about. I mean,
I've blown your mind.
Well, no, I'm thinking about what angle to approach that from. Like, what do you optimize for? Also, do you mind if I take a quick break, a 1-minute break, and be back while I think about this?
Sure.
Hey, we'll handle it in the edit. 1 second. Someone's
okay.
Talking.
Okay. All right. For those of you who are watching the live stream, someone knocked on Drew's door and he had to get it. I'm going to use this chance because I don't know when this is going to end, but we still have some people on here. We are doing, for those of you who don't know about the Cloud Native Geospatial Forum, we did an event in Utah this year at the end of April, early May at Snowbird. It was fantastic. Everyone loved it. We polled everybody at the end of it and we got like 5 stars. Like, I don't know, 97% of people said they would come back and they loved it. So we're doing it again. So you're hearing it here first. We just lost a follower, but anyway, we're going to be doing the Cloud Native Geo Forum conference again, October 6th to 9th, not next week, but October 6th to 9th, 2026. So we're going to do it in the fall next year, but we're going to do it again. We'll have a landing page up before too long. And we'll have links to share out. But anyhow, it's very exciting. Alex left another comment. So exactly. Like, so there's Alex left this comment saying that, a lot of journalism, Reddit, and orgs like Wikimedia are doing with their enterprise APIs is locking them down. I think this is fine. I think people were coming out of like Web 2.0 era, and I think a lot of the excitement around having open APIs is understandable. But now we're just realizing now we have about a decade of knowledge to understand this has a cost.
Well, I mean, the other thing that's crazy about it too is like a lot of the Web 2.0 dream is being enabled by LLMs, but like now you go to the meme, like not like that. We dreamed and we loved the idea of a semantic web that you could ask questions and just access things. And it has been delivered to us, and it has been delivered not as an open force, but as an intermediating force. And now we're having lots of second questions about that.
So, I mean, we're going to have to figure it out. But I think what I would want to say is that we should be, it's fine. I think we should just be sort of sober about this and say, if we want to have reliable access to data in these ways, someone should pay for it. And what's interesting about ChatGPT is that people pay for ChatGPT. Like I pay for ChatGPT. It should have a research budget. Like some fractions of those pennies could go towards maintaining accurate, up-to-date data about school enrollment in America or whatever it is, like whatever kind of research I want to do.
Yeah.
There's actually money flowing because that kind of stuff was never going to be supported by an ad model.
Yeah. I mean, I don't know. It's going to be supported by an ad model eventually. Don't worry, it'll come. I don't know if you've seen the announcements OpenAI has made over the last couple of days. They're very much ad model friendly.
They're selling stuff through ChatGPT.
They're selling stuff. They want to give you a morning report where they browse the web for you and go find all the things you should be looking at, and that's going to have an ad in there. I mean,
it's brutal.
I mean, well, and this is but also I'm going to play devil's advocate to you because,
sure.
if there's one thing I get frustrated about in the open space is people saying, well, we should be paid. This idea
Right.
of like, oh, you're making money off of my library, you
Hmm.
should be paying us. You are freeloading. And it bothers me because um I agree with it. Like in a perfect world, I want every open project funded, like that
Yeah.
gets usage. But your argument cannot be, we should be paid, you're making money
No.
off of it. It needs to be a realistic, practical, pragmatic exchange for how you deliver that. And so I do think there is like a mechanism, like there could be a mechanism for the way information gets distributed and access to it. And I think it's going to get really fraught right now because like the whole ad model is going to go crazy. Not just because it's going to get intermediated. Like the ad model in
Right.
the like is based on attention, and if we have these agents out there making decisions for us as proxies, that attention is now theoretically infinite. How do we kind of govern that relationship, and how does it get remonetized? Um,
Yeah.
so
Man. So look, I'm with you. I mean, my I'm putting in the chat. I'm just flog my own blog, but like the Gazelle's blog post from
sure,
year and a half ago, where I'm just like, one thing I haven't been explicit about, and there's going to be like a follow up blog post at some point, but like where like the idea of a Gazelle is that we should have entities that are, I would say non-owned, not owned by investors exclusively, that provide some sort of, usually are providing data, but that they are accountable to the market. And so I'm with you in that the conversation needs to go way beyond like we should be paid, which is, there's so much entitlement in the open community. It drives me insane. Like
yeah.
you should give me data for free too. Like you should. It's
and
public
and
good. And I'm
and
like,
everybody should be giving data away for free. Like I
yeah,
want people to think about their monetization policies because it gives them the control over their own future, which is, and
that's
that's what,
that's right.
and that is like me clarifying when I get frustrated when I hear open people begging for money, because that's what it is. They don't have the leverage. They've never thought about it before, and
That's
now are
right.
finally have to coming back to it. It is, I encourage everyone to think about money before you think you need to, because it's going to help control your future and your destiny and not end up being beholden to something else.
That's exactly right. And it's hard. And I say like I'm fighting two fronts um, with my sort of notions of gazelles and new public sector organizations. One is the easy one where it's like these billionaires have too much power, and some of these tech companies are like out of control with too much power. People are like, yeah, blah blah blah. We all kind of agree. The harder battle to fight, though, is for me to go to my colleagues in the open world and say, like, hey, we should maybe put a price on what we do and think about the value of what we're doing and see if the market supports that. And they're like, what? Like, there's, I believe that there's a huge uh, part of the sort of the cultural legacy of the philanthropic world comes from
Yes.
like European aristocracy, where they're like, we do not touch money. Like, I don't work for a
Or
living.
the money, like it
Like
goes back
it's
to
like a
like,
leisure class stuff.
yeah, well, and I think it goes back to like Stallman and others, where it's like, the cathedral and the bazaar type thing, which is like,
Yeah.
we should have this free exchange, everything is better with exchange, everything is better with open, but then we get issues often.
Well, you get
uh
steamrolled by people who actually have market power.
I see the
Right.
Ruby community right now. I don't know if you've been following that, but that's a
A
good
little
example.
bit. I saw they created a foundation.
No,
Tell me
it's
more.
there's a governance argument right now about who has control over what and what org has control over what,
Hmm.
and how much power does Shopify have as the big person bankrolling everything in this example. And so you
Interesting.
have all of these things that like stack together until you get into these uncomfortable scenarios when the incentives are not aligned, or not aligned the way you expect them to be aligned, which is
Yeah.
almost just as dangerous. And so like I do think there is a market for data, but like you have to provide the utility of it. And I do think like it comes
Yeah.
back to data discovery and data democratization. But like we're not going to create these things just because we want them. We have to create them and build the structures around them.
That's right. That's right. And so that's what I need to figure out is like, can we create some sort of mechanism whereby look, I mean, I'll just talk about Source, like the vision for Source. This is the Source Cooperative Podcast. Is like we have this notion of you have data products, which in our opinion is a data product is a collection of files of objects that have been shared by an organization or a person that you know who they are. Like that's
Yeah.
fundamental to Source, which is like this is a data product that came from Planet, the satellite company, for example.
Yeah.
Um, that it is up to the user, the beholder, to determine whether or not that data is worth their time. And what is interesting to figure out is how could we communicate that to an LLM? Like, could somebody say like, "Hey, ChatGPT, I want to know this information, but I only want to get data directly from Planet or from NASA or the Census Department or whatever it is." Um, and then it's up to OpenAI to determine. It's like, yeah, sure, we're willing to throw a few shekels over to Planet to get access to this data and return it. So because my assumption is that OpenAI is just going to hoover up whatever they can get.
Yeah.
Is the credibility and provenance of data actually important to consumers? Maybe sometimes, but it's weird because who's making that determination? It's many times not going to be the user. It's just they're going to be asking
Yeah.
an idle
I,
question.
I also think it matters in the domain. And that's where you're seeing a lot
Right.
of random startups. Like I was just talking to someone who's starting a company that's based on medical spending records. So looking at like Medicare receipts and Medicaid
Yeah.
receipts. And like it's a highly regulated industry. You can't have hallucinations. You have to have provenance figure in when you start to build different products with this. And like they've had to build their own custom pipeline. And this is
Yeah.
getting into the question Alex just asked. Like, I wonder how RAG changes the playbook. Even if you build your own custom pipeline, they were doing text to SQL, which is kind of the predating of RAG, the first use case of text to SQL. But then they're having to figure out, all right, well, how do we then go validate and
Yeah.
subsequently confirm? And so getting back to what you're saying with RAG is like subsequent confirmation. And that's kind of where the messiness comes in. The challenge is that like they're working on one specific domain. Their surface area is a lot tighter, both in terms of the
Yeah.
questions being asked and the data that can ask it. So their needle in a haystack exercise is different. And you're going to see the same types of companies come up with law. So like, how do I cite legal
Right.
cases and actually they exist so I don't get chewed out by a judge and told to like, go F off. And you're going to see that in each little domain where there's regulation, where there's penalties, and where you can sell that higher quality. I think the challenge that Anthropic and OpenAI and all these guys have is like there's really two markets right now, which is like their chatbot market and their coding market. And so like
Yeah.
they'll care about citation and coding stuff. The rest, they're just like, all right, how do I drive down hallucination and like citation? They do have citation benchmarks. There are citation benchmarks and evals for people to get to go judge their ability to correctly name things without hallucinating.
Yeah.
But coming back to what you're saying, I think the challenge here too is that you're not with LLMs. You also have to worry about multiple stages in the pipeline. So what I mean by that is like there's different stages when you build the pipeline. You have the pre-training, which is
Yeah.
like when you train on the super messy common crawl type data that builds up your kind of base English capabilities or base language capabilities and establishes your knowledge base. Then
Yeah.
you have post training. Post training is like when you teach the model how to talk with an interface. That's when you train it to reason. That's when you train it to chat and go back and forth. That's when you train it to use tools. And then after that, people might fine tune it, or they might put further tools on top of that, like data, RAG, other similar things.
Yeah.
And so what you're talking about is providing function from basically post training all the way through to fine tuning, to tool deployment, to framework around it, to the actual application. It's this wide spectrum of applicability that
Yeah.
also has different pricing terms as you start to come in.
Right.
And the problem I have with paying it is just like, I worry about, it's one thing if you're Reddit and you cover everything. It's another thing if you're a really, really, really narrow niche. because
Yeah.
again, you're selling into a model that does everything. So how do they value that use case to justify your acquisition?
Yeah. Well, I mean, so this is where
As I drink with an
we're
Anthropic sticker on my water bottle.
that's cool, man. I wish I had an Anthropic sticker. uh I should put I've got Cloud Native Geo stickers here.
I have one of those.
Nice. Okay. No, I mean this. So Alex brings up a really interesting point here, though. That's very important. Is like you're mentioning if you're working in a very very narrow space, the applicability of whatever you're putting out there is very broad. I am 100% like my perspective on like the best gazelles create far more value than they capture. Right? They should be
Yes.
the kind of thing that's like only putting something out there, that's quite small and simple, and you can vouch for it. And then what people can do with it, go nuts. If people can become billionaires off of it, that's great. With climate stuff, this is just what we have to acknowledge, like head on, is the fact that like we were actually talking about this right before we started rolling, is that like we are at this point where we are actually talking about making interventions to perturb the environment in order to protect the world as as it suits humans, the roughly however many of us there are right now, basically to cool it off. Where we're going to make this decision now. Like we're going to gather up a bunch of climate data, a bunch of information about the planet, and it will be used for us to manipulate the environment in a way that is much more deliberate than we have done in the past. As we discussed, we've been messing with the environment quite a bit, not deliberately, but now we're like, oh, we're gonna do this sort of stuff on purpose. This has huge repercussions on like global governance, and we do have to figure out models that can allow us to make huge volumes of data available reliably. And I would say like they absolutely should be available to AIs. But just who pays for that? Somebody's got to pay for it. And I'm with you. The answer should not be, well, we should get paid to do it.
Well, that's just like, I thought that you were going to say the answer is not communism, or something similar.
No, but I mean, I do think, that's the other thing, is that like we don't have the luxury of being too idealistic now, which is like ideally it wouldn't be shaking down billionaires, but there are enough billionaires around that like we should be shaking them down. I think philanthropy has a role to play here. I'm very interested in endowments for guaranteeing access to data over time. So there's something to be done here, but it will be. This is a huge challenge. It's an exciting challenge, though.
I think that comes down to discovery, and I think that's like one of the big challenges, which is like,
right.
I mean, like that's so I shared a paper with Jed yesterday, which is going brand new. Just a PhD student came out with it yesterday. I'm going to link it. And oh wait, let me find the link I sent you. And it's about teaching LLMs to search for data and assess data. And I think of it as a natural extension of, one of the first things that happened when ChatGPT came out in that first year is there was a lot of text to SQL applications. I think it's a further extension of layers upon that, which is, hey, I'm going to understand a data source, build a representation artifact that is queryable.
Yeah.
So that then we can kind of query it on top of that. And so I think we're starting to see these systems. And like the good news is, like, here's the thing that I do think is incredibly valuable is like you look at this application and you can see why a company would fund it, because you can say, all right, would Databricks fund this? Would AWS fund this? Would Microsoft fund this? Like, would Tableau fund this? 100% they would, because they want people to find more data and the right data. Because if you find more data and the right data and it's valuable to you, you have to generate the compute to actually utilize that. And and so I do think that we're going to see things that are aligned with these functionalities when it comes to data discovery, because there is a huge market opportunity for it. And I do think like maybe that's the value that gets put on, which is not the access to the data, but the discovery of the data and the service of finding that.
Yeah.
And I would be that to me is like that would be a huge problem to be solved for tons of enterprises that I've talked to.
Hmm. Okay. Well, very relevant to what I want to do. So I'm gonna read it. This So Camilla asks a question, an important question. So does the inability of for some sort of royalty model disappear with the complexity and lack of explainability of how inputs are ultimately used in these models at the end of the day? So yeah, basically, so it's like, yeah, OpenAI, ChatGPT says like, yeah, we just got the coolest data from the Gates Foundation. Here's our answer, and it's like
Yeah.
a lot
I
of people
mean,
are gonna be like, okay, I trust your interpretation of this.
yeah. Let me tell you a story based off that.
Okay.
So I am one of the best ways to learn about new companies, especially new models. And this is something. So at Place IQ, we cared about privacy a lot, and we embraced new privacy mechanisms, regulations. We designed our systems with privacy in mind, and so I learned a lot about privacy during those eras. When OpenAI came out with ChatGPT and they launched ChatGPT and they launched the model, um, I knew something how the model was made. And so the first thing I'm like is like, there's a lot of privacy issues that are inherent in this, especially because once you train the model, coming out and selecting the data from the model that it learned from your private data is
Yeah.
basically impossible. You can only kind of add it. You can't go in and surgically remove it.
Yeah.
So, um, so as just for fun, because I'm weird, I filed a CCPA request
Okay.
with to OpenAI. CCPA request is a California privacy regulation that allows you to contact any company that has your data, and you have to say, "Hey, do you have my PII, my private personally
Yeah.
identifiable data? What is it?" And I also have the right to correct it or delete it if I require.
Hmm.
So you read their privacy policy, and it was all about the accounts you create when you create an account. It wasn't about the model or the training data they used for the model. They seem to have kind of deliberately skirted that question because it would be
Yeah.
a really big question. But at the same time, it's still PII and it still have it. And
Yeah.
I know for a fact that they had my website because I know my website's in Common Crawl.
Yep.
And so I filed the request, and this was like in the first year after ChatGPT, and like the person who was on the other line had no idea what to do with it.
Yeah.
Um, and uh, and they're like, "Well, here's your," and I'm like, "No, I want to know about the training data." And they're like, "I don't know." So it kept. I would go through periods of very quiet, and then it would get elevated, and then it would get very
Yeah.
quiet, and then it was elevated. And finally, they're just like, "Well, your email's not in our training data. We have processes for removing your email."
Hmm.
So I used the prompt exploit to get
Okay.
my email out of ChatGPT. So you can use all sorts of tricks to get around its alignment and safety protocols. And I did that.
Yeah.
And I got it to say Drew Brunig's email is what Drew Brunig's email is. I'm not going to
Yeah.
say it here. So I emailed them back and said, here is proof that, you have my email. Somewhere
Yeah.
in your databanks, it exists. And they're like, "Can you share the prompt?" Like, can it, like they got really like it's got elevated. And finally, they closed the issue because they said, "Well, your email is actually something that could be really easily guessed. And we could have learned it from other things and then
Hmm.
inferred the naming pattern. And so that's how it came out."
Oh man.
And so, but this is the crazy thing, but it's still my email. So from a
Right.
privacy perspective, like it still happened. The email existed. Whether it
Yeah.
guessed it or not is kind of immaterial, especially if it guessed it, then it falls afoul of the CAN Spam Act, which is
Yeah.
using software to automate the guessing of like brute forcing emails. If it didn't guess it, then it has a PII in my training data, which it almost certainly does.
Yeah.
And like I'm not going to lawyer up and go fight this fight but it's like a good example of like, even they can't tell what was the model was trained on. And so to Camilla's question, like the royalty model does kind of disappear because there's kind of different scenarios you can plan for, which is, did the model just hallucinate it? Did the
Yeah.
model figure it out based on the fact that it had seen previous patterns that are similar to that? And your question combined with the weights would manage to evoke your email? Or is it
Yeah.
recalling it from the weights buried deep in its kind of the depths of the weight? And so like there
Right.
will be ways where they try to do this, but like Anthropic just a couple months ago had a big thing. It's like, hey, we can explain what's actually happening inside these
Right.
models. And they could, but they had to train a special model just for explainability. And then they had to train a different model. And it was like a model that was the equivalent of like Claude 2. Like,
Yeah.
and then they had another one that looked at it. And then it would have to go through the output. And it was like 2 expert researchers would have to spend 2 months of their time just unbundling all the traces to figure out what actually happened for one query. So like
Right.
it's not a scalable mechanism, like, and it doesn't even work on the largest models. So yes, no one knows where the data is coming from. In fact, a lot of people say like that's why reasoning models are net good, because you can kind of see the logic of
Yeah.
how they arrive at their conclusion. But it, I think it is, yeah, it's a challenge.
Yeah. Yeah. I mean, well, this is kind of, again, sort of going to the philosophy of source, is that like you should be able to view source. So the model can't be explained, but like whenever possible, there should be some sort of like auditable layer of data.
Yeah,
That's not always going to happen, but like there are things. I mean, I'm going back to Alex's point about like climate data. Like if we're talking about environmental data, where this is deliberately being shared so that we can impact the environment, which has an impact on like everyone's lives.
yeah.
That there are layers of the internet that have to be auditable. And yes, the large companies, they're gonna want to have plenty of secret sauce in their models, but there's some stuff that can't be secret.
But like,
We
so
should
then
fight
like,
for being auditable.
I don't know. Like, I don't think you can make the models auditable. I think we're past that term.
Yeah.
Like,
That's no, yeah, I agree. I don't think we're making the models auditable, but at least you should be able to say, we know where some of this data came from, and you can do your own research if you want to.
yeah, it's funny because I do think that like a lot of labs would like that. The problem is
Yeah.
that like they see their competition as like actively stealing their stuff.
Yeah.
And so like how do you enforce that internationally?
Yeah.
Is the big question that comes in. And then also the desire to not fall behind, you know, other countries, I think is the other issue that you start to get into the
Yeah.
politics of the thing.
Yeah. Yeah.
So like, I don't know. Like I do think like like getting into the goal of like training data products so that LLMs can understand them. Like, is that what you're like angling at? And if that's the case, like I think it's like you need to make them like Brian Bishkoff talks about the map versus the terrain when it comes to creating data systems that LLMs can query. Is like you do have to create that thing that fits within the context well and allows them to kind of navigate and negotiate with it.
Right. And that's what I'm saying. That's what I was trying to say before, is like we could create a great catalog at Source Cooperative and talk to our friends, or I need to make friends at Anthropic and OpenAI. I've got a few, but like, and be like, do you want to use this catalog? And if you use this catalog, are you willing to pay to access stuff from it? Like, how do you train a model to know that data is worth paying for versus not paying for? I don't know. I mean, and I don't know if it could just be sort of a brute force thing, which is to say, OpenAI agrees that, I'm going to use the Gates Foundation again for, it's just like that the Gates Foundation, it maintains a lot of useful data. Actually, a better example is Facts USA, another Microsoft guy, Ballmer, who created it's USA Facts, which is his nonprofit that shares
Great outlet.
statistical data. Yeah, fantastic. And they say, like, OpenAI is like, Ballmer can't afford to keep this thing running himself, so we're going to pay. This is where the argument falls apart with both Gates and Ballmer. Is like, these are groups that do not need to be charging for access to this data, but it still, we want to have a market for data to make sure that it's continually being produced.
I do think like one of the things there is like getting in the provenance stack. Which I do think is like, it's like if you're merging data sets, you're going to have a ranking stack order for which ones you trust more than others. And like, so like, I think that's the service that may be a thing, which
Yeah.
is validating and normalizing the data so that it can be referenced confidently.
Yeah.
That to me is like that's the service to provide, is
Yeah.
that like, because I love the question of like when does an LLM know when to pay the data, or
Yeah.
like when does it present that option, and like
Yeah.
what do you think goes into that question? Like what do you think are the inputs that you can think about in that?
Well, right. So I mean, again, like what I've said about source is that like source, where what you find at source are files that have been put there by people or organizations who you may or may not trust, but you at least know who put them there. And so then the question is how we're building a UI for source that we want people to be able to tell at first sight whether or
Yeah.
not the data they find there is worth their time or not. We then have to answer the same question for a model. Is like, is this worth my time? Is this worth me spending some of my research budget on? And I think part of that just has to be like brute force through like partnerships to say that like OpenAI recognizes this as a value, as a useful data source. Um, does it make sense to charge for the data at that point based on some metering thing, at fractions of a penny, or is it just like it's a partnership where they pay for to just go in and out, whatever you get as much as they want.
Yeah,
I
I
don't
do
know.
think it's like, and that's the thing, which is like you are the thing that is vouching for the data. I think is the service
Yeah,
that is provided. But then now you need to be a quality clearinghouse.
that's right. Well, right. We have to have all so that okay. So here we go, and then we got to start wrapping this up. But like, what one thing that there's a bunch of stuff that we can do once we have these. So we have these files. We know who produced them. We can also have DOIs, right? So bear with me if you cringe at the notion of DOIs that I sometimes do, but we can say this data actually gets cited a lot. We could track how many citations the data has gotten. Um, we also have metrics that we want to share about like how much the data gets used. Hugging Face is great at this, like on their datasets product, which I love, and it's kind of like my envy. There's so much signal when you get to a Hugging Face dataset landing page. Like there's a lot of signal for you to be able to tell, like, is this being used or not? Um, and that's one way of motivating it. I mean, it's the way you shop on Amazon and it's like this is a bestseller. So you're like, okay, if the whole market agrees that this is a good thing to buy, then it's probably good enough for me to buy too. Um, and so, but it's a matter of communicating that both to humans and to agents.
I think that's, I mean,
Um,
maybe you need to build a benchmark. Maybe you need to build a benchmark on like quality retrieval from source data sets, which
yeah,
is like, can you correctly augment? And so I think that to me is like an interesting thing, which is, can you correctly augment site and um, without hallucination? Because like that's a challenge, which is like you may get the
right.
right pull, but then you don't adhere to the prompt and you rely on something in your weights. Um, so it's just like it's kind of like a recall on a moving target data set, um, which I think is a really interesting idea.
Hmm. Okay. Well, I'm gonna have to talk to you about that another time
Because like I mean
because
that's
I'm
the challenge. Like it's is you have a bunch of data, you want to basically check against it and then validate that it actually is repeating what it repeats back.
yeah,
Because
right.
I think that's the thing, which is like having high quality data isn't enough. You need to have high quality data, and then you need to ship the yardstick for measuring that high quality data when used in violence.
Yeah. All right. Well, the lesson from this conversation is benchmarks. Like we got to talk about benchmark design, not
Well,
just designing great data products, but
I think benchmarks are, because like this comes back to Common Crawl, which is like Common Crawl didn't do anything to its data. It just made it easier to access.
right.
Didn't make any choices or anything like that. But
Yeah.
I do think it's a really good exercise for like, all right, if Gil launched Common Crawl to build a better Google or build a better information recall, or to
Right.
not have Google monopolize it, the benchmark he should ship is like, if you're building a search engine, like here's the queries and here's the ID records that you should be finding within your thing
Yeah.
to like do this and like you can start to rank against it.
Yeah.
I do think even if you don't ship a benchmark, performing the exercise of what benchmark you would ship for the data product you're looking to ship
Yeah.
is a good exercise because it forces you to say, well, what do I want people to be able to do with this?
Right.
And then it focuses your kind of the way you package it up.
Yeah. Yeah. Boy. A lot of, I mean, but so many consequential decisions that come from that. So
Yeah.
Okay.
So who's building the temporal benchmark? Who do we assign that to?
That's Tyler Erickson. Will be built. No, it's useful feedback from him. We actually have a bit of funding right now to work on some GeoAI benchmarking work. So
that was Tyler.
Yeah. Anyway, this has been awesome. I couldn't be happier with our first episode. We'll get this out there. We got a link. Michelle cooked up website for CNG Conference 2026. So mark your calendars. It's official. There's a URL. So, oh yeah, Drew, I announced this while you were answering the door. We're doing CNG 2026. Same location, nice. But in the fall, 6th to 9th of October.
Ooh, so no snow.
No snow, which
that's
some people
big plus for me.
See, thank you. I'm glad you said that because people are like, oh no, like I like skiing. It's like a few people have the time and energy to ski. I think most people wanted to get out on the mountain and just couldn't because there was too much snow. So
yeah.
Anyway, thanks so much, man. We are going to do this again. You're not going to be. I predict you'll be a many times repeat guest. And thank you everyone for tuning in. This has been a lot of fun to do it with the live chat. And so I really appreciate everybody who chimed in.
Awesome.
Anything else?
No.
Do you have anything to plug?
No. Okay. I'll be at the Spatial Data Science Conference talking about GERS, talking about standards. Yeah, now I'm just thinking about evals, man.
All right. Well, stay tuned. We've got some work going on evals too. So, all right. Bye, everybody.
Later, Jed. Always a pleasure.
Bye.
Bye.